Hello everyone. So I want to review this PDF file that I posted on Canvas very briefly for you guys. Um, you guys hopefully have watched the previous videos that I posted on uh, the concept of linked list. Now we're just going to see like a brief review of some of the concepts that you've already seen. So we mentioned that linked list basically is a list of nodes that get linked together through a pointer. Each node is either like made of a structure or is made of like a class. So it's basically an object of a structure or class that has two parts. One part data, one part the link. The link is a pointer that points to the next node, right? So we have a head pointer that points to the head of the list, and the tail of the pointer contains a pointer that has a null, that's a null pointer basically. It basically doesn't point to anything. That basically indicates that this is going to be the last node of the linked list. So there are advantages for using linked list. The advantages of using linked list over arrays is basically inserting and deleting nodes, inserting and deleting elements is going to be much easier than doing it for the arrays. So that's why we use linked list. Here you can see an example of a node. So for example, structure book. This part, the first three strings are data, and then we have a pointer pointing to the next node. This is another structure that basically can be node for another linked list. And you have to know that these nodes are basically occupied in the dynamic memory. So that's why we have to use the new keyword to create these nodes. And one important aspect of linked list is that you have to be careful about memory leak. So like once you want to delete a node, you have to make sure to deallocate the memory, because these are dynamic memories occupied in the heap. So the allocation and deallocation is very important for the linked list. I just want to show you one example using this visualization website. This is an online compiler. I don't recommend to use this for your assignments or quizzes. I use it just for educational purposes to show you how things are actually done in the memory. So let's look at this program. Let me make it smaller so that we can see the whole thing. So let's just visualize it. It's going to take a few seconds. So here we have 3 pointers of type. So let's first look at this. We have a structure called node. If I do it again, I'll do this one capitalized. It's better to start the name of classes or a structure with a capital letter. But it has the data, which is an integer, and it has a pointer pointing to a node. We have 3 pointers, H, N, and T. So basically H is short for head, N is probably short for next, and T is probably short for temp. Okay. So when we say N is equal to new node, then N is going to point to a new node. N arrow data. You guys should be familiar with the concept of arrow operator. If you forgot about it, arrow operator is basically a combination of dereference operator. So you're dereferencing a pointer to get to the object, and a dot operator. So to access the data field of this node, which is pointed by N, we use the arrow operator. And arrow data means that like we want to put 1 inside this the data field of this node. T equal to N, H equal to N. So one concept that some people get confused with when we say like one pointer is equal to another pointer, it means that we want this pointer, the T, to be pointing to exactly where N is pointing to. They have the same kind, all of them are node star. So when we say T is equal to N, it means that we want to basically store the address of this node, which is inside N, into the T and H. So we want T and H also be pointing to the same node. So this is going to be what's happening here. And this visualization, this part, I don't like it because it shows this pointer pointing only to the data, but it should show that it's actually pointing to the node, not just to the data field of it. It's just like this is one thing that this pointer is pointing to. N equal to new node, so we're going to allocate another node. N arrow data equal to 2. T arrow next is equal to N. T arrow next is going to be this pointer. It's equal to N. It means that I want this pointer to point to exactly where N is pointing to. So this is going to point here. Next line. N again is equal to new node, so N arrow data equal to 3. T arrow next equal to N. And this continues. So this is basically how you can create a linked list. And look at this. We put null at the last pointer. So this is the tail of the list. This is head of the list. The head pointer points to the head of the list. And how do we know that this is the last node? Its pointer is a null pointer. And let's say like we are done. So we have to deallocate these nodes, right? Do we have to do from top to the bottom or from bottom to the top? What do you guys think? If we remove this one first, then we don't have any other pointer pointing to the second node, right? So we can't get rid of this one anymore. So we're gonna go from this way, from tail to the head. It says delete N. N is pointing here, so it's gonna delete the last node. T arrow next is equal to null. So now this is gonna be our tail. So this is what's happening here. We delete that one. Now this is we will make this one equal to null pointer. We delete this one, and eventually we delete the head. So this is, I just wanted to show you, this is how you can create a linked list. It's like nodes that are chained together. Okay. The difference between arrays and linked lists is that arrays, the sequence of numbers or strings or characters that are located in memory, in contiguous memory locations. But for linked lists, it's not like that. One node can be in one part of memory, the second node can be very far from it, the third node can be far from both of them, and so on. Okay, but they're just linked together using the pointer of the node. And I just wanted to also emphasize that you don't have to call it node, right? Like you can have like different structures for different applications. You can call it whatever you want, or you can call this one data or anything you want. The next or link, or like these are common names to be used for the pointers. As I explained in the previous video, one of the main application of linked list are adding and deleting nodes. One thing that you have to be very careful about is that once you write a code, for example, to insert a node or delete a node, you have to make sure that it works for every scenario, not just for one case. You have to make sure that, oh, what if I want to have to insert it in the beginning of the linked list? What if I want to insert it at the end of the linked list? What if I want to insert it in the middle? What if the linked list is empty? What if the linked list only has one node? So you have to consider different scenarios. So try to test your code for different cases. Okay, I'm just gonna show this code one more time, adding and deleting a node. You already saw this in the class, but let's just see this one more time. Here, we actually put the linked list as a class. So we have the class list, and as a private member of it, we have the structure node. I didn't want to write node star all the time, so I renamed this to node pointer. So type def, actually this might not be, this is like a C format, it's not needed here. Excuse me. 3 pointers, head, current, and temp. Constructor, a function, a member function for adding a node, a member function for deleting a node, a member function for printing the linked list. Okay, let's visualize this. I hope it works. Okay, perfect. So list A, which function is called here? We're gonna call the default constructor. So it's gonna go to the default constructor. Gonna jump to the default constructor. It makes all these pointers null pointers. Okay, so this is the object of our linked list. Now it's gonna call the function add node. Okay, so it jumps to this function, it allocate a new node. Always remember that whenever a member function is called, we have an automatically created pointer called this that points to the calling object. This is like how it's shown, because A was the calling object, it called this member function, now this is pointing to it. And this is the parameter that we have, the argument that we have passed to the parameter of this function. So this is the first node that we want to create. Make the pointer null, add the data there. If head is equal to null, if head is not equal to null. So that's what I mentioned, like you have to be careful. You have to consider different cases. Is my linked list empty or not empty? So in this case, because our linked list was empty, we have to change the head pointer. Okay, so the head pointer is gonna change, and done. Now the second one, again, we call add node, this time with the value 5. It's gonna happen again. Okay, so let me go through this one. So this time, because our linked list is not empty, we don't have to change the head. What we have to do is basically traverse through the linked list to find the tail of the linked list, and then change this pointer so that it points to where n is pointing to. Now, because we only have one node, it only takes one iteration inside this loop. We only spend one iteration inside the loop. It finds the tail and change the pointer, and that's it. Next time we want to add a node, again, allocate a new pointer. So now this time we're going to start and traverse through the linked list from head to tail. How do we find the tail? As soon as the pointer is equal to null, that's how we find the tail. So this is how things are going to go, and we find the tail, and then at the end of it we make this second node point, the pointer of the second node point to the third node. Okay, now another function, member function that we have is print list. Let's see what it does. It jumps here. Okay, again, it has a excuse me, the current, which is a pointer. So what we always use for traversing through a linked list is pointers. We use this current pointer to traverse through the linked list, to iterate through the linked list. So as long as current is not equal to null, as long as it is pointing to something, print current arrow data. So print the data value of the nodes. So it's going to print 3 then 5, then 8, and that's it. We're done. It's going to jump back here. Now it says delete node 3. So here we wrote a function that deletes the node that has the data value 3. Okay? So in this case, if you delete this one, you have to make sure that you have to change the head, right? So you have to consider these kind of scenarios. If you delete 5, you don't need to change the head. But like if you delete 3, the head of the pointer, the head of the linked list has to be this one now, right? So let's see what this function does. We go here. We have another pointer here. We start pointing to the beginning of the linked list, and because this is um, the head, it's not gonna go. We find the excuse me. We find um, the value, the node that has to be deleted, right? We make sure that we have a pointer pointing to the next node. We deleted the first node, and we made the head pointing to the new node. Okay, I want you to try this yourself. That's why I'm going so fast. I don't want you to just memorize the code and duplicate this. I want you to do it yourself, try it yourself, and the same thing is going to happen again and again and again. So that's good enough for this. So you know how to add a delete a node. Please try to write this code yourself and consider different scenarios. So as mentioned here, linked list is made of nodes that can be either a structure, it can also be classes. It's a usually a good thing to uh, rename the pointer to something that's easier to use. As you saw that, like I called it node pointer, for example, in the previous example. We have the head of the list that always we need a pointer pointing to the head of the list. So if you want to pass a linked list to a function, you just need to pass this head pointer. We also, the pointer part of the tail has to be a null pointer so that we know this is the last node of the linked list. Regarding the arrow operator, as I mentioned earlier, arrow operator is a combination of dereference and dot operator. So basically, it always on the left side of it, you have a pointer pointing to an object. So you want to dereference that pointer to get to the object and then access one of its member variables or call one of its member functions, fields or methods. So you have to get used to working with the arrow operator. Again, like here it emphasizes that the tail pointer has to be null. So for pointers, it's better to use null pointer. There is no difference between null and null pointer. The only difference is that if you have a scenario like this, that we have a function called, like we have overloaded this function. In one function we take an integer pointer, in the other one we take an integer. Now if you pass null, you would have a problem because null can be considered 0 or it can be also considered a null pointer, right? So this confusion between just like integer and integer star might happen here. So null can be just like number 0 or can be a null pointer, but null pointer is just like a null pointer. Okay, so that's the difference between null and null pointer. An empty list, what's an empty list? Basically, let's assume that you have a linked list and you try to delete all the nodes. What you end up with is an empty linked list. So it's basically just a head pointer that points to nothing. A head pointer that's a null pointer. Okay, in many applications, you have to consider the chance of working some operations on a linked list. So you have to consider that as one of your scenarios. So for example, if you're asked to delete a node from a linked list, you have to write your code so that it works even for an empty linked list. Or if you're inserting something to a linked list, you have to write your code so that it works for an empty linked list as well. Here's another example for inserting a node. So we already covered this. Again, I want you to try this yourself, and then like you can analyze these examples here. This also like wanted to emphasize that over here I have used global variables. Usually using global variables is not a good it's not a good practice. This part is just like only for educational purposes. So I just wanted to show you that, for example, here the head pointer, I have defined it as a global variable. I just wanted you to see the complications and implications of having global variables and what that involves. Again, another example that shows how to check if a linked list is empty, how to insert a node at the beginning of the linked list, how to insert it anywhere else, how to remove, how to print the linked list, and different things. So, and what we've seen so far, it's called a singly linked list. It has one pointer that points to the next node. Again, like pointer that points to the next node. Okay. One problem with the linked list is that we don't have random access. In arrays, you have index, right? You have indices that you can call different elements by their index. But in linked list, we don't have the index. We have to traverse through the linked list from head to tail. For example, if I need to get to 4, I have to go from 0, go to 1, 2, 3, and then finally get to 4. There is another kind of linked list that would have two pointers, one moving forward, one moving backward. Okay, and then again, for the head and for the tail, we would have a pointer that the previous pointer for the head is null, and the next pointer for the tail is equal to null. The rest of them point to the adjacent nodes. Okay, so you see the next pointer of the first node points to the second node, and the previous pointer of the second node points to the first node. This is called a doubly linked list. We don't cover this in our course, but it has many applications. Actually, we're going to cover it later on, but we don't, in the concept of linked list, we don't implement this in our course. But this is like something that we're going to see later as well. Um, one thing that is easier to do with doubly linked lists. Now this time, if I need to access 4, I don't need to I don't need to traverse through 4 different excuse me, nodes to get here. I would have a tail pointer that points to the 4, and I can access it here. So we have like we basically have a two-way street rather than a one-way street. Again, this is like pros and cons, and like we already covered this. General rule that if you want to if you want to insert or delete a node in a linked list, you need a pointer to traverse through the linked list, and usually you need you need a pointer to traverse through the linked list, and usually you want that pointer to point to the node just before the position you want to insert or delete. Okay, that's not written in a stone, so it's not a rule that you always have to follow. In different applications you might actually need more pointers. You might need like 2 pointers, sometimes 3 pointers, but just like that's basically how we traverse, how we iterate through the linked list, how we walk through the linked list using a pointer, and we move that pointer to point to different nodes of the linked list. I have some code analysis questions in my lecture notes usually. So what I want is like you basically try to visualize this yourself. Try to draw different nodes and see how this code would work. So I'll leave it up to you to do this one. We compared arrays and linked lists. So one advantage of array has having random access. The advantage of linked list is basically making it easier to insert or delete an element from a linked list. We also talked about pointers as iterators. So you can see here, for example, we have a pointer of type node star. We initialize it with the head address of the head of the linked list. Basically, it's the same as our head pointer, and we update it every time by moving it one node ahead. So iterate is equal to iterate arrow link. This is the pointer of each node, and we stop until we get to the tail. Okay, sometimes this condition for different applications, it's either the pointer not equal to null, or depending on the application, it might be the pointer arrow link is not equal to null, or pointer arrow next is not equal to null. So you have to pay attention to your application. In the for example, in the function that we want to print all the elements, all the data values of the node elements, we want to make sure that we also print the data of the last node. So that's why the condition is written like this. This is again inserting a node at the beginning of the linked list. This is just like a very easy example. I want you to again try to do this yourself. I also analyze this on the whiteboard, so I'm not going to do it again here, but try to do it yourself. Insert a node at the nth position. Again, let's just analyze this together. Okay, so we start. So we have a head pointer that's equal to null. Now we want to insert a node with the data value 2 at the first node. So let's see how that works. We would have a pointer current arrow data is equal to 2, current arrow next is equal to null. Okay, so that's what I meant, that you have to consider that is this the first node or is it not the head. If it's the head, we have to change the head pointer. So that's the case. So head is gonna change and we are done. The second node, we're gonna go through the same thing. So you can see that we use this pointer, we use this pointer to point to the new node. We change the data, and over here we use this pointer temp to traverse through the linked list. We initialize it with the head and then it moves, and that's how the link between these two is created. And this goes on. I don't want to waste your time, and basically it shows how to insert a node at the nth position. You can see that even we can again put a node in the first place and so on. Again, please try to do this yourself. Try not to use global variables. This is just like for your information. Using global variables is not recommended. It makes your program very messy and hard to manage. Similar to this, um, deleting a node at the nth position, I want to raise your attention to this part. Node star ampersand. So this is basically passing a pointer to a function by reference. Why do we pass it by reference? Because we might need to change this head pointer. Let's say if you want to delete the first node, if you want to delete the first node, then the head pointer has to be pointing to the second node, right? So that's why we didn't want to pass a copy of the head pointer. We want to pass the head pointer itself. So that's why it was passed by reference. This is what this node is. This note is saying here. And this example shows how to delete a node at the nth position. Again, we covered this on the whiteboard. So please try to do this program yourself first and then look at the solution. We covered this, how to reverse a linked list. We covered this already in previous videos, so I'm not going to go over this again. There's a very good YouTube video that explains this process. Also, this is possible to do recursively, which we're going to see later. And also I visualize this in this link, so you can also visualize it yourself to see how the linked list is reversed. Also, like cover here how to create a doubly linked list. You can see that if you want to have a doubly linked list, you need to have two pointers, one pointing to the next node, one pointing to the previous node. Okay, so these two examples show examples of doubly linked lists. Again, I provided visual implementation of them. So that's basically it for. Just like remember that when you delete a node, you have to consider memory leaks. All these nodes are dynamic data, dynamic memory. So if you delete them, you have to make sure to deallocate them, not just changing the pointer. Bypassing a node, it's not gonna be good enough. You have to consider memory leak. Also, like, wanted to show you that it's not always just structure. You can have a node that's basically a class. In that case, because your pointer and data becomes private, you need to have mutators and accessors, or getters and setters, to basically change the value of the pointer or the data. So in this case, you see that if you have a class, it has the data and it has the pointer. So for each of them, we have a getter and a setter. This is just an example of linked list with class instead of structure, and you can see that we have getters and setters, and instead of just directly changing the link and data value, we have to use setter and getter. So this basically shows the insert, print, and search functions for this example. Another example that basically like shows like how we iterate through a linked list. This can be written using a while loop, or it can be done using a for loop. I cover both of them in the examples here, so you can see that. Some good examples that I want you to work on. Another code analysis example. I want you to basically grab a piece of paper and visualize this, what happens to these two pointers. This is the append example that I solved in a previous video. The code is given here. So basically you have to traverse through one linked list to find the tail and make this tail, the pointer of the tail, to point to the head of the new linked list or the other linked list. This is similar to the example that I gave you as a quiz. This is a very good example. Remove duplicates. So this is an exercise that I want you to try on. So like if there are multiple of the same instance in a linked list, remove duplicates. How can you do that? So this is a very good example. It's not easy, but it's a very good example. This is the zigzag example. Again, we covered in a previous video. The code for it is given here. It's not very easy to do it yourself, but as soon as like you visualize it yourself and figure out what needs to be done, so it's not that difficult to implement. So one of my recommendations for you is like first try to figure out how this needs to be done. Grab a piece of paper, draw it, and then once you figure out what the algorithm should look like, implementing it is not going to be that challenging. Some more examples or exercises for you guys to work on. I would ask the TA to show you like couple of these examples, solve a couple of these examples for you. But please try to tackle them yourself first. And if you have any problem, you can always email me. Some acknowledgement for people that I grabbed this slides from. Uh, thank you so much. This is Puya, and that was the end of our lecture. Thank you.